Hey guys, boy, let's continue a little bit more on experimentation. Let me emphasize this is if you are trying to pass the AP psychology exam, this is important. Okay, so let's take a look at this scenario and let's identify the important experimental vocabulary. All right, so we've got an experiment here. Smithers thinks that a special juice will increase the productivity of workers. Creates two groups of 50 workers each and assigns each group the same task. In this case, they're supposed to staple a set of papers. Group A is given the special juice to drink while they work. Group B is not given the special juice. After an hour, Smithers counts how many stacks of papers each group has made. Group A made 1,587 stacks. Group B made a lot more, like over 2,000 stacks. Okay, so let's take this information and let's do something with it. Experiment, all right, and hit pause because you need to think about this. I'm not going to stop too long, but you need to hit pause and think about this stuff. What is the experimental group? Okay, so is it group A or group B? It's group A. The experimental group got the drink. The drink was supposedly going to cause better work. And so group B is the control group because they did not receive the drink. What is the independent variable? Okay, the independent variable is what you do to the experimental group that you don't do to the control group. So the independent variable would be the drink. The dependent variable. The dependent variable is what are you measuring? And in this case, it is how much work that they get done. How would you operationalize that? By how many papers they stapled. That's the operationalized definition, okay? But the dependent variable is how much work they get done. So what is the conclusion? Did the independent variable cause the dependent variable? Did the drink cause more work being done? The answer is no. Group A, who got the drink, did less work than Group B. Okay, so the drink doesn't work. As a matter of fact, it does the opposite of that. So how would you improve this experiment? Hit pause, read it again, and think about this. Well, one thing that I would do is I don't see any random assignment here. What you're supposed to do is you're supposed to take everybody in the population in the group that you're studying that's randomly selected maybe. So Smithers should randomly select workers from the nuclear power plant, and then he should randomly assign them to either group A or group B. He should randomly assign them. Otherwise, you've got issues like there's that video I showed you about the soccer players versus the hockey players, and they didn't randomly assign the two to the alcohol and to the non-alcohol group. That's a problem, and that's a problem with this experiment here. Okay, if you just go and you just take all the if you take the brainiac people and you put them in one group and then you take the muscle people and put them in a different group, that's not good experimentation. You have to randomly assign the groups to either the experimental group or the control group. That's how I would improve this experiment. You could probably come up with something better. Okay, that's one thing that stands out to me. Let's try another. Homer notices that his shower is covered in a strange green slime. His friend Barney tells him that coconut juice will get rid of the green slime. Homer decides to check this out by spraying half the shower with coconut juice. He sprays the other half of the shower with water. After 3 days of treatment, there is no change in the appearance of the green slime on either side of the shower. Okay, so we're not studying people here, but it still applies. So what would be the experimental group? The experimental group received the coconut juice. And then the control group received what? Water. What is the independent variable? The coconut juice. What is the dependent variable? The dependent variable is getting rid of the slime. Conclusion, after 3 days of treatment, there is no change, so it didn't work. That's the conclusion. How would you improve this experiment? I don't know. It took me a minute to think about, but I guess replication, trying it on different bathtubs. That would be one thing you could do. That's all I could come up with on that one. Replication. You have to replicate your science. Otherwise, if you do it once, it's just a fluke. All right. Bart believes that mice exposed to radio waves will become extra strong. He decides to perform this experiment by placing 10 mice near a radio for 5 hours. He compared these 10 mice to another 10 mice that had not been exposed. His test consisted of a heavy block of wood that blocked the mouse food. He found that 8 out of 10 of the radio-waved mice were able to push the block away. 7 out of 10 of the other mice were able to do the same. Okay, so 8 out of 10 who got the radioactive treatment were able to do it. 7 out of 10 of the control group were not. Were able to do it. All right, so what's the experimental group? That would be the mice that received the radioactive treatment. The control group did not receive the treatment. What is the independent variable? That would be the exposure to the radio waves. What is the dependent variable? The ability to move the block. Conclusion? Well, what do you think? The mice that received 8 out of 10 were able to do it, but the control group, 7 out of 10, were able to move the block. Is that one mouse enough to say that the radiation treatment worked, the radio wave treatment worked? I would say no. I would say that just I would say in this case, that is not statistically significant. I think that that could be due to random chance. It could be due to genetics, or something like that. I don't think one mouse in one experiment is enough to have statistically significant difference. So I would say that the radio waves did not cause the dependent variable. So I would say that that the radio waves didn't work based on what I'm seeing here. How would you improve this experiment? I don't know. I guess maybe random assignment. I don't know if you need to do that with mice. Definitely a bigger population, definitely a bigger sample size, and definitely replication. You got to do this again with other mice in another location at a different university. All right, Krusty was told that Itchy Brand powder was the newest, best thing on the market. It even claims to cause 50% longer lasting itches. Interested in this product, he buys the itching powder and compares it to his usual product. One test subject, A, is sprinkled with the usual itching powder. Another test subject, B, was sprinkled with the Itchy Brand itching powder. Subject A reported having itches for 30 minutes. Subject B reported to have itches for 45 minutes. Okay, I know it's weird to think of a powder that causes itches, but think of it as a prank. So the experimental group, that would be the person who received the itchy brand. So that would be group B. And then the control group would receive the normal itchy powder. That would be test subject A. The independent variable would be the itchy bran powder, the new powder, the one that subject B received. The dependent variable would be what you are measuring. What are we measuring? The time of the itches. Conclusion? Well, the hypothesis was that Krusty claimed that the itchy bran powder would last 50% longer. And the results said that subject B did 45 minutes and subject A did 30 minutes of itching. So I would say, yes, the powder works 50% longer. How would you improve this experiment? Well, it needs to be replicated and it needs to have more people to do it. You know, just one person, that's too small of a sample. Okay. All right. Now this is important. Lisa is working on a science project. Her task is to answer the question, does Rogooti, which is a commercial hair product, affect the speed of hair growth? Her family is willing to volunteer for the experiment. Okay, one thing that you need to do, and it's hard to get people to do it if I'm not there, but you need to have the ability to design your own experiment. So you need to think about this. Hit pause and think about this and really, how would you design an experiment to determine if a hair growth product actually works? I gave you some terms to think about: random assignment, independent variable, dependent variable, control group, replication, statistically significant. Okay, look that up if you need to, or look at the PowerPoint or at the other video. Okay, hit pause and think about it. All right, so you need a group of people. It doesn't need to be the family, but you do need a group of volunteers, and they do need to be volunteers. You cannot trick or coerce people into being in your science project unless there's a really good reason to do it. Okay, so you need volunteers, and then you need to take these volunteers and ideally they're not just volunteers, but ideally they're randomly selected from the population that you're trying to study. Then you take these randomly selected people and then you randomly assign them to either receive the Rogooti or to receive a placebo. That's random assignment. Now, what is the independent variable? That would be the Rogooti. What is the dependent variable? Well, how would you operationalize this? I guess you would take a ruler and measure hair growth on people who are going to use it. The control group, those are the people who received a placebo, maybe some kind of harmless, non-effective something that you rub on your head. Replication, you would have to do this. Somebody else would have to do this again at a different university in a different laboratory with different people, but with the same methodology. Statistically significant. So let's say your hair grows 3 millimeters without the product, but with the product, it grows 3.25 millimeters with the product. Is that extra 0.25 millimeters, is that statistically significant, or is that just due to random chance? You know, that's what statistical significance is about. Is it due to random chance, or is it due to the independent variable, the Rogooti? Okay. All right, that's enough for this video. All right, thanks guys, and then we'll do part 2 of the scientific experimentation.